Welcome to In 5 Minutes. In this video clip, we will discuss the second receiver which is used for the reception of DSB-FC signal. It is called Superheterodyne receiver. This receiver is going to overcome drawbacks of the TRF receiver that we have discussed in the previous video clip. Let us understand the block diagram first. There is an antenna through which the signal will be received into the receiver. Because the signal travels through the wireless channel from transmitter to the receiver side, it will be highly attenuated when it is received, and hence before it is given to any further processing, it needs to be amplified. But please remember that more the number of amplifiers we have, more will be the number of bandpass filters also, because at the input of every amplifier we need a bandpass filter, as we had seen in case of TRF receiver. If you have more number of bandpass filters, that means you will have variable capacitors in every bandpass filter, and hence more number of variable capacitors which need to be ganged together, and that will bring back the first problem of the TRF receiver. So we don't want to increase the number of RF amplifiers in the beginning of the receiver. So you can see in this diagram we have got just one RF amplifier block. That RF stage is nothing but the RF amplifier, and hence there is only one capacitor in the input tank circuit of this RF amplifier which needs to be ganged with few more capacitors. We'll see what are that. But I repeat, we don't have series of RF amplifiers, and hence this is going to reduce the number of capacitors which need to be ganged together. So output of first RF amplifier will be amplified to minimum desired value that needs to be there for the further processing. See, the reason we are having first RF amplifier is because the incoming signal is greatly attenuated of very low amplitude. It needs to be amplified to certain minimum level so that I can give it to the later blocks, and hence we need at least one RF amplifier in the beginning, but not too many RF amplifiers to keep the number of variable capacitors to minimum value. Let us quickly recall that we need to include two features in this receiver. The first is that the frequency of operation should be constant, and second that the frequency of operation should be low as well. Let us see how that will be done. Through antenna, we have received double sideband full carrier signal which is present in the range FC minus FM to FC to FC plus FM. I am going to call this carrier frequency also as the station frequency. So we are going to use another notation for FC which is FS, station frequency. So you can see the incoming signal is present around station frequency FS. As you tune the receiver from one station to another station, your carrier frequency will change, and hence the station frequency will also change. The output of the RF stage is the signal present around Fs. Please remember that Fs is nothing but the carrier frequency of the specific signal which is being received. Now, if you observe carefully, we have some new blocks in the receiver. The next block is a mixer. Mixer we have discussed in one of the clips previously. Mixer always takes two input signals. It uses a non-linear device, and that non-linear device is responsible to generate various combinations of frequencies at the output of the mixer. This time the two frequencies, the two signals which are entering into the mixer are the station frequency Fs, around which the entire DSB-FC signal is present, and the second signal is output of the local oscillator. The local oscillator will generate single frequency signal, and this single frequency signal will have the frequency of FO. So FO is the frequency generated by local oscillator. Oscillator will be a circuit that will generate sinusoidal signal of frequency FO. It is called local oscillator because it is present in the receiver locally. It will generate sinusoidal signal locally in the receiver. So let us see what are the inputs to the mixer. It is signal with frequency Fs and second signal with frequency FO. We know that at the output of the mixer, all the types of frequencies will be present. Fundamental frequency Fs, FO, all the harmonics of the two frequencies, and the next is the cross products. Now cross products are nothing but the combinations of MFO plus minus NFS. out of all these frequencies, we are going to select one combination which is FO minus FS. So at the output of the mixer, there will be a bandpass filter which will accept only one range of frequencies which are in the form of FO minus FS. Now let us see what this frequency going to be like at the output of mixer.